Okay, so a couple of practice problems having to do with um, primarily tertiary and quaternary structure, mostly tertiary, but what type of attraction would you expect between the R groups of each of the following amino acids in a tertiary structure? So if we have cysteine and cysteine, so we've talked about this one specifically, this makes a disulfide bond. So to do these, your first step is going to be to go and identify what these particular amino acids are. So cysteine is the one with our thiol at the end. So these two thiols I know are going to form that disulfide bond. Okay, let's look at the next one. So aspartic acid and lysine are two amino acids that were given. If we look back at our chart, we'll see that aspartic acid is going to be a positively charged, or I'm sorry, negatively charged amino acid. It's one of our charged amino acids and it is negative. Lysine is one of our charged amino acids that is positive. So between these two, I'd expect to have a salt bridge because we have two charged amino acids. Threonine and water. Okay, so threonine has an alcohol on it. Water, we know H2O. So I would expect between the OH, either the oxygen can have hydrogen bonding or the hydrogen can have hydrogen bonding with water. So I would expect lots of hydrogen bonding with water. Last one, phenylalanine and tryptophan. These are both kind of those big aromatic looking, ring looking things. They are both hydrophobic. So I would say they are, or they're both nonpolar. So they would be hydrophobic interactions. Next question, would you expect valine and leucine to be found in the interior or exterior of a protein? Why? So first thing we need to do is identify what these particular amino acids are. So valine and leucine. So valine is the one that looks like a V. Let's do this. Valine's the one that looks like a V. Leucine. Oh, that's isoleucine. Leucine looks like a V, but it's extended out a little bit. So these are all carbon R groups. So these are going to be nonpolar amino acids. So because they're nonpolar, I'd expect them to have hydrophobic interactions. And so it would want to be on the interior of a protein. Are the following conditions responsible for primary, secondary, tertiary, or quaternary structure? Disulfide bonds between peptide chains or portions of a peptide chain. So anything that has to do with more than one peptide chain coming together, that is going to be quaternary structure. If it's within the same peptide chain, then it's technically tertiary. So let's put both. So between peptide chains would be quaternary. Within the same peptide chain, tertiary. Number B, peptide bonds that form an amino acid chain. So this is how peptide bonds forming together gives us our primary structure. That is the order of our peptides or order of our amino acids. Hydrogen bonds between I and I+4 amino acids of a peptide chain. So that is what our alpha helice is, or alpha helix. So this is going to be secondary. Excuse me. Okay, great job going through those problems.